Apologize for my ending video one early. I was actually hoping to do like one full video and not break it into two, but my dog was upstairs getting sick and I couldn't like ignore it. So I had to go tend to her. So sorry for that abrupt ending, and that's just life and distance learning with COVID, I guess. So here we go. Fingers crossed that she stays quiet. So 7.4 video 2, the next thing for your notes is to talk about reference angles. All right. Basically, a reference angle helps take really big angle measures and helps us visualize them better. Okay. So any quadrant, the reference angle would be an angle that measures from the x-axis to the terminal side. And it's always positive. I would write that down to remember that a reference angle always has to be positive. And I give a little clue here where I say butterflies and bow ties, not hourglasses. What I mean by that is if you had like a reference angle in quadrant 1, 2, 3, or 4, they connect with the x-axis. So it makes what looks like a butterfly or a bow tie. Where if you have your angle and you connect it with the y-axis, it looks like an hourglass. That's not what we want. So you always are going to connect from the x-axis to the terminal side. So you want to write that down. All right. So this first one is actually kind of a tough example because the reference angle is the same as the actual angle itself. So this is an example of reference angles in quadrant 1. So what's happening here is the angle it's asking about is 60 degrees. So I know here's 0, here's 90. So I would guess 60. Well, the initial side will be on the positive x-axis, and the terminal side will be right up to about there. And there is that angle. The circle with the line is theta. It is used a lot to represent angle measures. So what we'll do then is connecting it to the nearest x-axis is easy. It's right there. And so then the reference angle, you use the little dash there to represent a reference angle, is also 60 degrees. So when your angle is in quadrant 1, the reference angle will be the same. So it seems kind of weird, like an example that doesn't really help you very much. This one will be a little bit more helpful for you, okay? So this time the angle we're looking at is 150 degrees. Well, if I think about 0 degrees, 90 degrees, and 180, it would make sense for me to say that the initial side is here, positive x-axis always, and then it's going to rotate up past 90, but not all the way to 180. I would guess it would go to right about there. So from here to here, that is that angle measure of 150. Now the reference angle says, look at the terminal side, drop down to the nearest x-axis. So the triangle we're looking at is right here, which means the reference angle is that angle tucked in between the x-axis and the terminal side. So I represent it with theta with a dash. And let's think about, what would that measure be? How big is that? What is that reference angle measure right there? If this is 150, well, think of it as how much further do you have to go to get to 180? If you're at 150, you have to go 30 more degrees to get to 180. So if you have an angle of 150, its reference angle will be 30. And this seems kind of weird, like what's the point of reference angles? Like I said, it will come into play soon because it is the easiest dealing with everything in quadrant 1. And what a reference angle does, 30 degrees, does sit in quadrant 1. 60 degrees sits in quadrant 1. And so then when we do harder problems, if we can get something into quadrant 1, it just helps us a little bit. So the thing I would write down as a little reminder is when it's asking for reference angles, you ask yourself, where is the closest x-axis? And that's what you would drop it down to make that angle. Let's try a couple more. All right. So this one, we have an angle of 225. So let's kind of sketch where we think that's going to be. 0, 90, 180, 270. So 225 is going to land us down here in quadrant 3. So you have your initial side, that positive x-axis. It's going to rotate around past 180, but not quite to 270. So I'm going to just kind of guess somewhere in there. That is that angle of 225 right there. Okay. So now to find the reference angle, you take your terminal side and you connect it with the closest x-axis, which would be there. So then your reference angle is what's tucked in between your terminal side and the x-axis. Oops, that didn't draw very well. So there's your reference angle right there. And that's represented by theta with a dash. Now let's think about this. If this was 225 degrees, it's kind of like I went 180, I went 225, I want to back it up to 180. So to back it up, that would give me the reference angle. So I want to just take that 225, subtract 180 from it, and you end up with 45 degrees. So your reference angle is 45 degrees. Angle of 225, reference angle is 45. 45 degrees sits in quadrant 1, so it'll help us later to do things in quadrant 1 because it's just a little bit easier. Okay? So there was an example of quadrant 3, and then this theta of 310 is going to be our example of quadrant 4. All right? So if you have an angle at 310 degrees, we're at 0, 90, 180, 270, and then all the way around would get us to 360. So if you have that initial side on the positive x-axis, it's going to go all the way around. It's going to go past 90, past 80, past 270, not all the way to 360. It's going to stop at 310. Let's just make a guess where we think that is. I don't know, right there. So you draw, there is that angle theta of 310 degrees. So now the reference angle is you take your terminal side and you find the closest x-axis right there. So where is that angle made? Right there is your reference angle. It's the terminal side connecting with the nearest x-axis. So what would the measure of that be? The best way to think about it is if you go all the way around to 360, that's too far. We have to back it up to 310. So if we did 360 minus 310, you would see that there were 50 degrees left over. You got to 310, you had to go 50 more to make it all the way around. So 50 degrees is that reference angle. So there's some examples of how to find reference angles in all 4 quadrants. Now let's do 2 examples where we're going in the negative direction. All right, theta is negative 150, so that negative means we're going to go in that negative direction. So 0, negative 90, negative 180, negative 270, negative 360. So if we want to go negative 150, we have that initial side, the positive x-axis, and then if it's going to go down negative 90, that's not enough. If we keep going to 180, that's too much. So I'm going to guess that terminal side is somewhere in quadrant 3. And that gets me that theta of negative 150. Now I'm going to continue doing what I've been doing all along is I want to make a triangle that connects the terminal side to the nearest x-axis. And that angle right there at the origin is the reference angle. So let's think about that. What's happening here is if I've gone negative 150, how much further do I have to go to get to negative 180? Hopefully you're thinking, okay, you have to go negative 30 more. We're going in this negative direction. But do you remember what we said about reference angles? They're always positive. So even though I'm thinking of this reference angle here as a negative 30, let's take that absolute value and have it be a positive 30. That this will be, this would represent 30 degrees right here. Okay. And now lastly, if our angle theta is negative 315, we're going to go in that negative direction again. All right, if we start with our initial side on that positive x-axis, we're going to go the negative direction around. let's see. If we go this far, it's negative 90, negative 180, negative 270. I don't want to go all the way to negative 360, so I'll just make a guess. It's somewhere in quadrant 1 for that terminal side. I've gone 315 degrees around. And now I'm going to connect with the terminal side to the nearest positive x-axis. So the reference angle is right here. All right, if I've gone 360, if I've gone negative 315 and I want to go all the way around, I'm just going to think of it as positive, even though it's in that negative direction. I don't want to go 360. I only went 315. So that tells me there's 45 degrees left over. So that reference angle, always positive, of 45 degrees. All right. So there are some reference angles. All right, I think my dog is doing okay, so I'm not going to stop this video. I'm going to keep going to do a new kind of problem. This next kind of problem I really like. They're going to be something you use a lot, so don't skip this video. Watch it, write some things down. Here's an example. We're going to find the sine of 150 degrees, okay? Step 1. Let's do a little sketch, okay? A little sketch here. I would say, think about what 150 degrees looks like. If you have your positive, your initial side, then it's gonna go in the positive direction. It'll be somewhere between 90 and 180. So that 150 is gonna land in quadrant 2, and my reference angle is gonna be right there. Okay, so that's my little sketch. Now let's actually work on finding a reference angle. So I'm going to I should maybe make my sketch a little bit better to start. I'm going to make it a little bit bigger. I recall the initial side was here, and I guessed that the terminal side is somewhere up over there. All right, 150 degrees, there's that theta. Then I drop from the terminal side to the closest x-axis. So I get right here, this is going to be my reference angle. And let's think about it. Hopefully, without too much trouble, you can say, all right, if I've gone 150, how much more do I have to go to get to that 180? It would be 30. So my reference angle is 30 degrees. That's going to help me find the sine of 150. And now it's time to spend a little time in this triangle. If this is 30 degrees and I drop this guy straight down, he's going to be 90. That one's going to be 60. So it's a 30, 60, 90 triangle. This is why we were reviewing those special right triangles, because what will help us now is, let's think about this. In a 30, 60, 90, opposite the 30 will be n, opposite the 60 will be n root 3, and opposite the 90 will be 2n. And what we're going to do here is treat it with a ratio that our n equals 1. So we have a 1 root 3, and 2 times 1 is 2. So let's fill out our triangle. Opposite the 30 is 1, opposite the 60 is 1 root 3, or I'll just say root 3, and the side opposite the 90 degree angle gets a 2. Now let's think about that. There's a few funny things going on. The hypotenuse will always be positive. But what do we remember is true about quadrant 2? Remember how our x values are negative and our y values are positive? Because from the origin here, if we're going square root of 3 to the left, that's actually a negative square root of 3. And if we're going 1 up, that is a positive 1. So it's important that I put that negative root 3 there. The x value, the left or right one, has to be negative. So now I'm ready to find the sine of 150 degrees. Well, let's remember, sine is defined as opposite over hypotenuse. So what we're going to do is look at this triangle here to help us out. Well, opposite the reference angle is 1. And the hypotenuse of this triangle is 2. So the sine of 150 degrees is 1/2. And that's your answer. I know this seems totally weird, totally new, kind of new trig stuff. I really like it. I think this stuff is really fun, but it can feel tricky until you practice it, just like any math. So let's try another one. Next, we're going to stick with sine, I guess. We're going to find the sine of 300 degrees. Step 1, let's make a little sketch, okay? 300 degrees is going to sit in quadrant 4. You've got the initial side, and I'm going to guess it's going to be somewhere around there, 300. We're going to connect the triangle there, and our reference angle will be there. So let's think about it. That sketch, when we just very, very quickly sketch it, that lets us know that we're in quadrant 4. And in quadrant 4, we go to the right and down. So we remember our x value is positive, our y value is negative. And remember to think of the x value as your cosine, the y value as your sine. Just some different things we've talked about. Maybe it'll help us, maybe it won't. Next, let's draw a better picture and get an actual nice reference angle in here. All right, so if I know I'm in quadrant 4, I'm going to kind of repeat this sketch where I thought my initial side was here. And then I went around 300 degrees and ended somewhere around there, connecting the terminal side to the nearest x-axis. And here is that reference angle. This is the triangle that everything matters for. So that reference angle, if this was 300 degrees, how much further do I have to go to get to 360? 60 degrees. So there's my 60, here's my 90. Triangle sum would say that's 30. So I've got a 30, 60, 90 again. All right, that's nice. So let's remember what's going on here. Opposite the 30 is 1. The side opposite the 60 is root 3, and the side opposite the 90 is 2. If you're having trouble remembering that, so the reference angle, backing up, was 60 degrees. Step 3 is we're working on the special right triangles. That's what a really nice little thing here. Remember, if you have a 30, 60, 90, opposite the 30 is 1, opposite the 60 is root 3, opposite the 90 is 2. That's what I put in here in the right spots, but now we have to remember this plus minus. From the origin to the right, we go to the right to get to quadrant 4 so that 1 can stay positive, but we go down to get into quadrant 4, so this root 3 has to be a negative. So now I'm ready to actually evaluate. All right, so the sine of 300 degrees, I'm going to remember sine is opposite over hypotenuse. So when I go from the perspective of that reference angle, which side is the opposite? It would be this guy. The 2 is always the hypotenuse, it's always positive, and 1 will be the adjacent. So from the perspective of the 60, opposite is negative root 3, and hypotenuse is 2. So you're going to end up with this answer that the sine of 300 is a negative root 3 over 2. There's a lot there. You will get faster at these as you do them. All right, they will get much, much easier. Right now it feels kind of clunky. You'll get better. Let's try another one. Here's a cosine this time. All right. Cosine of 315 degrees. Well, we know 315 is in quadrant 4. Because it's somewhere between 270 and 360. We'll just make a guess on where we think it is. We'll go all the way around, and I'm just going to throw it into quadrant 4. I'm not going to concern myself too much of where it is. And let's find that reference angle right here, because when we connect the terminal side to the nearest x-axis, we see the triangle that we want. All right, so 315 degrees. Well, if I went all the way around, it'd be to 360, but I only want to go 315, so I can see I have a reference angle of 45 degrees. All right, something else to remember about quadrant 4, when I go to the right, it's plus. So the x value will be positive, the y value will be negative. So now that we add our special right triangles in, because this guy, I made this kind of small, is 45, and this guy is 90, I know I have a 45 down here as well. Sorry, I wish I had made that bigger. So let's remember our special right triangles. A 45, 45, 90 comes from taking a square, cutting it in half. So that means if you're looking at this right triangle here, The legs, those are the two sides that connect that right angle, will be 1. And then if you remember, the hypotenuse is a root 2 for a 45, 45, 90. So let's apply that up there to this triangle. Opposite the 90, the hypotenuse is a root 2. The hypotenuse will always be positive. Trying to make it a little bigger. And then the legs opposite the 45s are 1s. Now keep in mind from the origin, we go to the right. So this one stays positive, but then we go down. So that one has to be negative. All right. So now I'm ready to do the evaluation. Cosine of 315. Well, cosine is adjacent over hypotenuse. Well, from the perspective of this reference angle, I have the hypotenuse, I have the opposite, and I have the adjacent. So the adjacent looks like a positive 1. And the hypotenuse looks like a square root of 2. It's tempting to say that that's your final answer, but remember, we don't like radicals in the denominator. Hopefully you're getting better at rationalizing now. Remember, you multiply by a fraction that's equivalent to 1, and you would pick that root to put on the top and the bottom. So equivalent to 1. 1 times root 2 is root 2. Root 2 times root 2 is root 4. And we know square root of 4 equals 2. So our final answer here, is actually square root of 2 over 2. So the cosine of 315 degrees equals the square root of 2 over 2. And believe it or not, you guys, by doing this trig, you are in the stepping stones of calculus. It's really kind of cool to see. All right, let's keep going. Not on that page, though. This is a little bit of a different kind of problem, so you might want to kind of call this a different part. I almost made a separate video for it, but let's just keep it going. I would write this down. What measure describes the angle at -4, -3? We don't even really know what that means very much. All I know is I have a point at -4, -3, and I need to have an angle made out of that. So let's just do a little sketch. -4, -3 is going to put us in quadrant 3. 4 to the left, 3 down. Just like that. All right. Well, what do we know about angles that we've been dealing with? Our initial side is always that positive x-axis. It's going to go around, and the terminal side is going to go through that point of -4, -3. Okay. So the angle that they're kind of asking about is that one right there. We know it's going to be somewhere between 180 degrees when we're done and 270 because it's sitting into quadrant 3. Now let's work on making a reference angle. I'm going to connect that terminal side to the closest x-axis right there, so you can see like the triangle we're using is here, and my reference angle will sit right in there. Okay, now we have to figure this out a little bit. This side length of the triangle is -4 because we went 4 to the left. This side length will be a -3. And let's do a quick Pythagorean theorem to see what the hypotenuse is. So you've got this -3 squared plus a -4 squared equals the hypotenuse squared. So 9 plus 16. So it looks like the hypotenuse equals 5. So you've got the 5 right there. Okay, good. Now we have a lot of information. We have, what we have to do now is figure out what our reference angle is. I know that this is 90, but I just do not have enough information to know if this is a special right triangle or not. So what we're going to do is make some guesses. Let's guess that the sine of the reference angle is going to be what we need. Or we're going to guess the cosine of the reference angle is what we need. And then lastly, we're going to guess that the tangent of the reference angle is what we need. I'm not sure yet, but I do remember that sine is opposite over hypotenuse. I remember that cosine is adjacent over hypotenuse. And I remember that tangent is opposite over adjacent. So let's set some things up here. From the perspective of this reference angle, sine would be opposite over hypotenuse. Let's maybe label these. I already goofed it up. From the reference angle, the hypotenuse is 5 The -3 is across, it's the opposite, and the -4 would be the adjacent. So just by taking a minute to write those down, it could help. So opposite over hypotenuse is a -3/5. Adjacent over hypotenuse is a -4/5. And opposite over adjacent is a -3 over a -4. So we know it's really a +3/4 because those negatives will cancel. All right. Now, how do you solve for an angle measure? Remember, we're trying to figure out which reference angle makes sense here, and we don't really know which one. But to find an angle measure, hopefully you're getting really good at recognizing, oh yeah, I need to do the inverse sine to solve for theta. Down here, I would do the inverse cosine to solve for theta. Or down here, I would use the inverse tangent to solve for theta. So let's see what happens. So here we are doing, to find the angle, we're doing the inverse sine of -3/5. I think you get the idea. We'll do the inverse cosine of -4/5 and the inverse tangent of 3/4. For the sake of time, I'm going to do that calculator work for you because I think you know how to do it by now. But the inverse sine of -3/5 is -36.8. The inverse cosine of -4/5 is 143.1. And then the inverse tangent of 3/4 is you can't see that, is a 30, maybe I'm going to turn myself off for a second so we have more room, is a 36.8. So what I'm going to say here is, of these 3 possible reference angles, only one of them actually makes sense. Well, I'm thinking right away, I'm going to get rid of the sine because remember, reference angles are always positive, so we're not going to have a -1. I also think I can get rid of cosine 143. Reference angles are never going to be above 90 because remember, this reference angle goes from the x-axis to the terminal side. That's well below 90 degrees. 143 is way too big. All right. Let's hope here that 36.8, that the tangent one will make sense. I think 36.8 makes perfect sense. It's positive and it's between 0 and 90 degrees. So that's what we're going to go with. I believe that this little area right here, this angle is 36.8 degrees. So lots of kids would say, oh, that's the final answer there. But remember, way back when we started, the full measure actually starts on the positive x-axis and goes all the way around. So what we have to do is we go 180 degrees and then plus, so we got to 180, we got to add that little bit more, which was 36.8 degrees. So we end up with an angle measure of 216.8 degrees because we had to do that original 180 plus the reference angle of 36.8. I really like these problems. I think they're really fun. As you do a little more, you'll get better at guessing which one is going to be correct. But for now, the best thing to do is try all 3. You'll be able to eliminate 2 to get one more, or and have one left to know what the answer is. So let's try this one. I would love to maybe have you try it on your own, but that we're not in class. So I'm just going to keep ahead and let's do it. Let's take some notes. We're almost done. After this, we just have one more slide to go. All right. So this one says, what measure describes the angle at -3,1? Well, -3,1 is going to be up in quadrant 2, 3 to the left and 1 up. There's the point, -3,1. Remember what's happening here is your angle, it starts on that initial side, and then the terminal side will go through here. That's the angle measure we're looking for. So I know my final answer will be somewhere between 90 degrees and 180 because it ends in quadrant 2. And what we're going to have to do, again, shoot, I wish I had drawn this bigger. When will I learn? Is we'll connect this with the nearest x-axis. So our reference angle here, it will be what will help us. Once we find that reference angle, we'll take 180, subtract the reference angle, and what's left will be what we're looking for. All right, so let's label this a little bit. Let's do a Pythagorean theorem because I know this guy is -3 and this side of my triangle is 1. There's the 90 degrees right there. Let's do a Pythagorean theorem to get the hypotenuse. So I've got a 1 plus 9. So it looks like c squared equals 10. So c is the square root of 10. Hypotenuse is always positive. The hypotenuse is going to be square root of 10. You can see we're looking at this little triangle guy right here. Okay, now let's guess. I have no idea if the sine of the reference angle is going to be correct, the cosine, or the tangent. So we'll try and it'll end up being obvious which one works. So sine from the reference angle is opposite over hypotenuse. Well, that square root of 10 is the hypotenuse, and from the perspective of the reference angle, 1 will be the opposite and the -3 will be the adjacent. So when we look here, sine opposite over hypotenuse, 1 over square root of 10. Don't bother putting that in proper form now. It just doesn't matter. Cosine is -3 over square root of 10. We won't bother rationalizing that either. And then tangent opposite over adjacent is a 1 over a -3, so a -1/3. To find these angle measures, we'll do the inverse sine, the inverse cosine, and the inverse tangent to both sides. And I'm going to trust that you know how to use your calculator on this, so I'm just going to give you the answers. Is that the reference angle for sine is a positive 18.43. That shows promise. The reference angle for cosine is a positive 161.56. And if we use tangent, the reference angle will be a -18.4. Well, I'm going to get rid of tangent right away because I can't have a negative. I'm going to get rid of cosine right away because we can't have something 161 degrees. That is clearly between 0 and 90. That's the idea of a reference angle. 18.43, that totally fits. It's positive and it's between 0 and 90. So this little guy right here, this little angle right here is 18.43 degrees. So to finish this problem, though, we remember the angle we want is actually all of this. So we will do 180 minus 18.43, because the spinner, it's going not all the way to 180. You have to back it up that 18.43. And what does that even land us on? I think 161.6 degrees is the measure of that angle. Oh, we're so close. My dog's doing okay, so we're going to keep going. This is a big day. You're doing great, and it's worth it. Trig is fun. Once you understand it, it's fun. All right. Lastly, what I'm going to do for this example, it says sine of x. I'm going to change that to say sine of theta. Cosine of x, I'm going to change to say cosine of theta because we're more used to theta representing an angle measure. And what it's asking is for two possible values between 0 and 360, which seems a little strange to me because let's see what happens. When I have the sine of theta being 0.951056, let's think about what the value of theta is. So hopefully it makes sense to find that value of theta. You would take the inverse sine of both sides and plug that in your calculator, and it's like a 71.99. You could round that up to 72 degrees. So that's great. If you look on your picture, all right, 72 degrees, that's the initial side, and then the terminal side, 72 degrees, sits in quadrant 1, and there's 72 degrees right there. All right, quadrant 1, we're set. But it's asking for two possible values. So it's like, gosh, I got one right there in quadrant 1. What I want you to ask yourself is, where is sine positive? And here's where it comes back for you guys to remember that cosine is associated with the x value of an ordered pair. and sine is associated with the y value of an ordered pair. So you're basically, when you're saying where is the sine function positive, you want to know like where is y positive? And it certainly is positive in quadrant 1 because from the origin you go to the right and up. So both things are positive. What other quadrant are we positive in? Quadrant 4, when you go to the right and down, nope, that has a y value, that's negative. Quadrant 3, when you go to the left and down, both the x and y value are negative. So here in quadrant 2, from the origin, when you go to the left and up, you'll remember to the left and up, since the sine value is the y, then we know that our other possible value is going to be somewhere here in quadrant 2. So when it's asking for two values involving sine, one of them will be in quadrant 1, the other will be in quadrant 2. All right, so now how on earth can we find it? Well, use what you know about reference angles. Draw in a 72-degree reference angle in quadrant 2, okay? And let's think about then, where is that? We're not going a full 180. We're going 180 minus 72 to 108 degrees. So there's the second angle. The first one, real easy, sitting in quadrant 1 is 72 degrees. The second one that's a little harder to see has that same initial side, but it goes all the way to there at 108. So when it says two possible values, you would say theta could be 72 degrees or 108 degrees. There's the two possible values. All right, the next one, asking about cosine. Suppose the cosine of theta is this number, two possible values between 0 and 360. Well, let's right off the bat find the first one. That's easy. To separate the cosine and the theta, we're going to do the inverse cosine of that big number. And when you put that in your calculator, it is going to be, let's see if I can find it, it rounds right to about 67 degrees. So I'm trusting that you can put that in your calculator on your own. And now here's where a sketch becomes helpful. 67 degrees, nice and easy in quadrant 1. And does that make sense? This is a positive number, 0.03. So we're looking to see, where is the cosine positive? Well, is it positive here in quadrant 1? Yeah, because remember, from the origin, you go to the right and up, and the cosine is associated with the x value. The x value is definitely positive in quadrant 1. Where else is cosine positive? It's not positive in quadrant 2 because you go to the left and up, so the cosine's negative in quadrant 2. In quadrant 3, when you go to the left and down, both the cosine and the sine are negative. So quadrant 4 is where we're going to be, because quadrant 4, from the origin to get to quadrant 4, you go to the right and down. And the cosine is the x value, which is positive. So let's put in a reference angle of 67 in quadrant 4. Well, how can we figure out what that is? Because remember, it actually starts from the positive x-axis, and it's going to go all the way around just like that. So we are going to say we're not going to go 360. We're going to go 360 minus 67, which gets us to 293 degrees. So in this case, our angle could either be a positive 67 or a positive 293. Those are two angles between 0 and 360 that could get us this same answer. Let's just make sure we get that, because with our calculator, if we did cosine of, what was it, 67, there we get it, that 0.3907311, just like it said. And what happens when we hit cosine of 293? We get that same answer. Same thing for the first example where it was sine of 72. It was the 0.951, and then the second option was the sine of 108. Also gave us that same value of the 0.9510. Lots of trig stuff today. Let's just keep practicing. We're going to baby step our way through some trig, and you guys are going to be great. Thank you so much for getting this far into 7.4.